called Daniel Halali, a civil engineering student from Technical University. In this tutorial, we will calculate lateral earth pressure using GEO5. So here is GEO5 app. I've already launched it. So what we'll do is we move to our project. We now come to our project data. So you can name the project however we want to name. After naming, we click on OK. Then we come to our settings tab. After clicking the settings tab, you realize our pressure analysis has already been done. Per what they have here, they use columns, but since they use columns for our active and passive pressure, but since the wall in our diagram here is vertical, we will use ranking. Which I'll go ahead to edit. I'll change here to ranking, and I press OK. So now let's move on to our geometry. Now looking at our drawing, our wall height was 7 meters. So we come to the depth. We click on the depth, then we edit. We change it to 7. Then we click on OK. So in our drawing, you see the wall height has now been changed to 7. Okay. Then we now move to our profile tab. Okay. Since we have two soil profile, what we do next is to come to the add. Okay. So per our diagram, our depth, the first depth of interface here is 0. Then our second depth here is 4 meters. So we change, we come here. Okay. So we come to thickness of layer. We change it to 4. And we add. So our second profile starts from 4. So the depth of the second profile here will be 4. And the thickness is we change it to 3. Since we have no other profile to add, we click on cancel. Okay. So we now move to our soils. Okay. So so you can see it's showing not input because we haven't add anything relating to the soil. So we come downwards and click on add. Okay. So we have different properties of soil located here. Which we have the loose sand and then the dense sand. So we'll name our first sand, which is here, as our loose sand. Okay. So our unit weight for our sand is 16 kilonewton. This is the effective unit weight of our sand is 16 kilonewton. Then our angle of friction per the question is 32, and our cohesion here is 0. And our angle of friction too will be 0 as well. Okay. So we move to our saturated. Okay, so since the effective weight of our soil is saturated weight minus our unit weight of water, we now add the unit weight, which is 16 kilonewtons plus 9.8 kilonewtons, which will be equal to 25.81. So our 25.81. Okay, so we are done here. So we click on add. So you could see here that our first property of soil, which is the low sand, has been added here. So we now come, our second one is the dense sand. So we name it as a dense sand. Okay, so with our dense sand, since it's in a saturated unit weight of water, we will have to subtract the unit weight of water. So here will be 19 kilonewtons minus 9.81 kilonewtons, which will give us 9.19. Okay, so our angle of internal friction given in the diagram was 38, which is here. Our coefficient of cohesion of soil, was 0. Angle of friction was 0. Then our unit weight, our saturated unit weight, was given as 19, which is this one. The saturated weight will now be 19. Sorry, 19. We click on add. Okay, so we are done. So we press cancel. Then we move on to assign. Okay, so you realize that you check what we have here plus our diagram. You realize that we have low sand here and dense sand. So we now come to the properties here. We come to the properties here and we change here. We change it as our dense sand. Okay. Okay. So we now move on to our terrain. So looking at our diagram, it looks like our supports are in the same level. So we will choose the first one here. Okay, so we now move on to our water. So we will now locate where our water table, and per our drawing, our water table will be located at the depth of 4 meters. Comparing these drawings here, you pick the first one here. Okay, so you realize that it's written 1 here, which here is 4. So we edit here to 4. Okay. 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 So our water table is now located at the 4. So we now move to our surcharge. Which was given as Q in the diagram is 15 kilopascal. We now come to add. So since ours was given as Q, we name it as Q. Okay. And then per our surcharge given, our surcharge is a surface type, and then the type of load here is a permanent load. So our Q given here, which are 15 kilopascal, is also the same as 15 kilonewton per meter square. Then we click on our add. So since earthquake was not given, we now move on to our analysis. Okay. So our analysis, this is how our drawing is going to look like, and this is a graph showing our geometry of structure, our horizontal component, overall force, depth of centroid, vertical component, overall shift, and then our centroid. So you can now move on. If you want to share or you want to save, you can come here and save. If you want to print the details, this is it. This is how it looks like.